So I didn't feel like I could like get a video, not a video. I didn't feel like I did a really good explanation for your really helped me, Leah. So I'm gonna try to talk to you about what I meant by like a fundamental theorem of algebra, and I'll go step by step through that, and then through linear equations, one variable, linear inequalities, one variable, linear equations with multiple variables, and then possibly lines, if there's time for that. So first, let me just erase my whiteboard, which is doing some statistics. Okay, so this is going to be the fundamental theorem of algebra, basically. Well, there's actually a theorem that goes like. So this is of algebraic manipulation. This is the fundamental theorem of algebraic manipulation. So if x equals x, then fx equals fx. So what does that actually mean? So I'll give you an example. So we all know that 3 equals 3. So 1 second. Hopefully you can still see this well. So let's add 1 second, sorry. So 3 equals 3, right? Now, let's say I add 2 to both sides, right? Then 3 plus 2 is 5, so 5 equals 5. So another way of saying that is I've got this function, f, and for simplicity, we're going to say it takes in some parameter, and we'll call this parameter y. I'll make more sense because we'll have like, it also will be confusing. So fy equals y plus 2. Okay, so now let's put in f3. So f3 is equal to, well, so y is equal to 3. So we got y, which is 3, plus 2, which equals 5. Okay, and 5 equals f3. So in other words, if 3 equals 3, hopefully you can see this well, if 3 equals 3, then f3 equals f3, and we know f3 is 5, so 5 equals 5. Oh, that's a terrible 5. Okay, so another way to say that would be 3 equals 3. Okay, that implies 3 plus 2 equals 3 plus 2. Okay, and this should be really simple. Like, nobody's debating this. And the cool thing is, you can go all the way to quadratic formula with just a simple trick. And so I showed you on paper, but now I'm going to show you how to solve a system. Well, you already know how to solve them, but really get a sense of how you do it with this, which is the same way how you normally solve them, and we'll work from there. So, but before we do that, we'll start with, let's take the number 5. Or actually 6. Let's take number 6. Okay. So let's say that 6 equals 6, right? And now let's make x equals 6. So 6 equals 6 is obviously true, and x is equal to 6. Cool. So 6 equals 6, that's the same thing as saying x equals x, since 6 equals 6. But now we can do some manipulation. So let's think of it. So x equals x. Well, now let's choose a function. So I'm going to choose a function, fy is equal to 2y plus 1. Okay, well, so that means that if x equals x, then fx equals fx. Okay, so now we apply this. So y is equal to x, right? Because that's what we're putting in for y, we're putting in the variable x. Hopefully that isn't too confusing. So now we do 2y plus 1, but y is equal to x, see? So it's actually 2x plus 1. Hopefully you can see this well. So 2x plus 1, and that again is equal to 2x plus 1. But now we know that x is equal to 6. So that means 2x plus 1 is equal to 2 times 6 plus 1. And 2 times 6, that is going to be 12, right? So we get 12 plus 1, and 12 plus 1 is equal to 13. So 2x plus 1 is 13. Cool. And now instead of saying fx equals fx, right, which you know is 13, well, this is the same thing as fx equals f6. I probably confused you with this, which I'm sorry. Okay, well, what's f6? Well, that means y equals 6, and this is equal to 2y plus 1. So that's 2 times 6 plus 1, which is 12 plus 1, which is 13, which is the number we got right here. Great. So that means f x equals 6, then fx is equal to f6. That's awesome, and that's really cool. Okay, now, so that's what I mean by the fundamental theorem of algebra. So now there's two more things I want to say. So I'm gonna rewrite it, and we're gonna go from there. So, or algebraic manipulation. So fundamental theorem of algebraic manipulation. FTAM, fundamental theorem of algebraic manipulation, states that if x equals x, then fx equals fx. However, you're going to go to quadratics, and I want to say one thing. So this does not imply the converse. So in other words, fx equals fx, that does not imply x equals x. And so let me give you an example of it. So let's take the function fx is equal to x squared. Okay, so if we made a graph of it, we would see this kind of like U shape. Okay, that's called a parabola, and you're going to learn more about this later in algebra. But x squared, that just means x times x. So this is equal to x. Oh, sloppy. Okay, and now fundamental theorem algebra says, okay, so we know 3 equals 3. Okay, great. Then f3 equals f3. Okay, great. Okay, what's f3? Well, f3, that's just 3 squared, which is equal to 3 squared. Okay, now 3 squared, that's literally just 3 times 3. So that's 3 times 3 is equal to 3 times 3, which means 9 equals 9. Cool. But now, let's say that we have let's say we have 3 and negative 3. Now, we know 3 is not equal to negative 3. However, f3 is equal to f negative 3. The reason why is this is 3 squared, and this is negative 3 squared. And 3 times 3 is equal to negative 3 times negative 3, which means 9 is equal to 9. Okay, so this should not confuse you, but what this means is for this to work, I need equality originally. So, in other words, if I state x equals x, whatever, and it may not be stated like that, okay, I can use functions to derive x. But if I go the opposite way, and I say fx equals fx, that doesn't mean x is equal to x is necessarily true. But you'll get into that more in quadratics and stuff, and you still have useful information. But just like take that in the very back of your mind that while this is true, this is not necessarily true. Okay, hopefully that doesn't confuse you. But now let's go on to solving a problem. Okay, so 2x plus 1 is equal to 13 minus x. And these are actually the same number. And I'll actually tell you that by the end of this equation, we'll know all we're saying is 9 is equal to 9. Okay? And so we're actually just applying functions to 9. And the reason why is x is 4. And so 2 times 4 plus 1, 2 times 4 is 8, 8 plus 1 is 9, 13 minus 4 is 9. So we're just doing 9 equals 9. But I'll show you how to get there. Okay, so first, you can say functions, which they are. But you say they can add, subtract. So what we first want to do is we want to find the x's that's bigger, that's 2x. Okay, so we want to bring the other x over here. Great. And then we want to bring the thing that's not the x, just like the normal number, over here. Okay. So how are we going to do that? Well, we need to add an x to this side to cancel it out. And we need to subtract a 1 from this side to cancel it out. Okay. So, in other words, what I'm saying is we need a plus x, and we also need a minus 1. And these will work. So, I'm just going to do it one by one. So let's start with the x's. So I said we need a plus x. I'm not going to do stuff that will confuse you. So here is our function that we're going to construct. Fy is equal to y plus x. Remember, x is just some number. And even though we don't know it yet, we can still do that. This is actually just y plus 4 because x is 4. So remember, this is just a function. But now we can do it to both sides. So this is f 2x plus 1 is equal to f 13 minus x. Okay, great. So let's look at the left-hand side first. What's y? Well, y is what the argument is, which is this. So that means y equals 2x plus 1. Okay. So then f of y is equal to y plus x, right? And we know what y is. So y is going to be, this is 2x plus 1, and then we've got this plus x right here. Okay, well, 2x plus 1 plus x is just equal to 3x plus 1. Okay, so hopefully you can see that. And that makes sense. Okay, hopefully you got that now. So we know f2x plus 1 is equal to 3x plus 1. We just figured that out. Beautiful. So I'll write it right here. Great. Okay, so now let's do the right-hand side. So this is the right-hand side, and we'll do fy is equal to, well, that's, sorry, oh my gosh. So we got, so we got f13 minus x, or y is going to be the argument, which is 13 minus x. So y is equal to 13 minus x, because it's our argument. Okay, hopefully that makes sense. Now, f y, which is again 13 minus x, that is equal to y plus x. Okay, well, what's y? Y is 13 minus x, so it's 13 minus x plus x. And 13 minus x plus x is just 13. Okay, which means fy and y is just, so this is equal to 13. So fy is equal to 13. And we know what y is. We said y is 13 minus x since that's what we passed through the function. And y is just the argument. Is equal to, oh gosh. So f13 minus x is equal to 13. Okay, great. So we did that step, and we know this is true. So I'm going to erase that part and bring it up. Okay, so f2x plus 1, we figured that out. That's 3x plus 1. And f13 minus x is 13. Okay, so now I'm going to put that where I had all the stuff. Okay, so great. So that's equal to 13. Okay, and this is literally all the function we're doing is we're adding x to both sides. So 2x plus 1 plus x is equal to 13 minus x plus x. So again, you can think of like a scale, right? And they're both actually balanced since you say they're equal to. So whenever I add something to one side, I have to add something to the other side. Whenever I do blank to one side, I have to do blank to the other. Okay, so now what do you think our next function should be? Because, and what's the goal of our next function, right? Okay, well, the goal should be to help us figure out what x is. And it's easier if we just knew what 3x is equal to. So to do that, we want to subtract, we want to move this one over here. And what I mean by that is we want to make it where this new thing doesn't have a 1. Well, what would be a nice function for that? Well, it's simple. We just subtract 1 from both sides. Or we say fy is equal to y minus 1. So now we know 3x plus 1 is equal to 13. That implies f13 plus x is equal to f13. Now these are different functions. Actually, to help you out, I'll call the second function g. So g of y, and g of 13 plus x is equal to, g3x plus 1 is equal to g13. So I'll just name it something else to hopefully not confuse you. You can apply as many functions as you want, but these are different functions because we say they do different things, which they do. Okay, so what's g of 3x plus 1? Okay, well, first of all, we need to figure out what y is. Y is just an argument, which is 3x plus 1. So that means g 3x plus 1 is equal to y, which is our argument, 3x plus 1. Minus 1. So it's y minus 1, which is 3x plus 1 minus 1, which is 3x. Okay. Now for the other side, the right-hand side, we want to figure out what g13 is. well, what's y? Y is 13. So it's 13, which is y minus 1. And 13 minus 1 is 12. So that means that g3x plus 1, that is going to evaluate to 3x. And g13 is equal to 12. Okay, well, we're almost done. Last thing that we have to do is figure out what x is. Well, we know what 3x is, and now hopefully you believe me that it's 4 because 3 times 4 is 12. But what function we do? Well, it'd be really nice if we convert 3x to 3x to x, and there is a trick. We could divide it by 3. And so let's make our last function hy, which equals y divided by 3. Since these are equal, the output of the function is going to be equal. So, as we know, h3x is equal to h12. Okay, I am running out of room, but so let's figure out what h3x is. Well, the y is 3x. So, h3x is equal to 3x because that's y. This is y, which is also, it's y, divided by 3. 3x divided by 3 is x. Okay, so now h3x is equal to x. Now what's h12? Sorry, the bottom of the board is really hard to write without it wobbling. There's more torque on it. Y is equal to 12. These are both y. Well, you can see that's a little y and that's a y. So 12, and then what is it? It's y divided by 3. So 12 divided by 3, which is equal to 4. So we know x is equal to 4. And that's what I said before, and it checks out. Because now let's go to the top of the equation. Now we know x is equal to 4. Okay. X equals 4. Okay, again, so that means 2x plus 1, well that's 2 times 4 plus 1, which is 8 plus 1, which is 9. So this right here is 9. 9. And what's the other side? It's 13 minus x. That's 13 minus 4, which is 9. So 9 equals 9. Okay. Now what I showed you was really slow and tedious. But it's actually what you do every single time you do algebraic manipulation. You just don't do it that slowly. And so I'll show you a faster way of doing it. Okay. So if you got which x is higher, it's 2x minus x. Okay. So we want to keep the x's. So we want to move the x's to one side. So we add x to each side. That's the same thing as what our first function did, f of y. Okay, so that gets us 2x plus x plus 1 is 3x plus 1. Which is equal to 13 minus x plus x, which is 13. Okay, now we want to move that 1 to the 13. So we subtract 1 from both sides, right? This is our second function, g. So minus 1, minus 1. 3x plus 1 minus 1 is 3x. And 13 minus 1 is 12. And now finally, we do our last step, which is the divide by 3, which gets us 4 for that side. So we divide both sides by 3. So divide by 3, divide by 3. Okay, right? So 3x divided by 3 is x. And 12 divided by 3 is 4. So we get x equals 4, which is how you normally do it, but you're just defining the functions implicitly. This is our plus x. So this is our f of y right here. This is our g of y, and this is our h of y. Okay. Great. So now I'm going to make another equation, and I want you to try to solve it. Okay, so here's our equation. 1 minus 2x is equal to 7 plus x. So you should pause the video right now, and then in 5, I'm going to give the solution in 5, 4, 3, 2, 1. Okay, so I'm going to do it quicker this time. I'm going to do it like how I did at the end of the last example. Okay, so we want to figure out what side has the bigger x. Well, it's going to be this side. So we want to move this x over here. So to do that, we need to add 2 x's to both sides, because negative 2x plus 2x is 0. So our first function will add 2 x's to both sides of the equation. So plus 2x plus 2x. Okay, now let's evaluate it. Let's look at the left-hand side. 1 minus 2x plus 2x is just 1. Now on the other side, we've got 7 plus x plus 2x. Okay, x plus 2x is 3x, so we got 7 plus 3x. So 1 equals 7 plus 3x. Well, now we got the x's over here, we want to move the 7 to be on this side of the equation. So how do we do that? Well, we need to subtract 7 from this side, and since they're the same number, and our function is subtract 7, that means we subtract 7 here too, right? So we subtract 7 from both sides, because that's what our function's going to do. Okay, so 1 minus 7 is equal to 7 plus 3x minus 7. So let's look at this side first. 1 minus 7 is equal to negative 6. So negative 6 is equal to, now if we look at the other side, 7 plus 3x minus 7, well, that's just 3x. So negative 6 is equal to 3x. Finally, we need to divide both sides by 3. So to get x. So we do negative 7 divided by 3 and 3x divided by 3. Okay, so we get negative 2. So sorry, negative 6 divided by 3 is negative 2. So that's our left-hand side. The right-hand side is 3x divided by 3, which is just x. So negative 2 equals x, or x equals negative 2. Now with algebra, we can check our solution. So let's go back up here. So we've got 1 minus 2x. Okay. 1 minus 2x. Right? Well, what's x? X is negative 2. So we've got 1 minus 2 times negative 2. Okay, let's simplify this. This is going to be 1 minus, so 2 times negative 2 is negative 4. Well, 1 minus negative 4, that's the same as 1 plus 4, because you got a negative negative, which is a positive. So we get 1 plus 4, and 1 plus 4 is 5. So we get 5. So if x is negative 2, then 1 minus 2x is 5. Now, let's just double check and make sure that that's the solution. Okay. 7 plus x. Well, remember, x is negative 2, so it's 7 plus negative 2. That's the same thing as 7 minus 2. And 7 minus 2, 7 minus 2 is 5. Great, so we get 5 equals 5. Now here's the cool thing. Let's say that we messed up the math somewhere along the way, I don't know. And we got x is equal to 4. Let's see what the math would do if we got x equals 4. Okay, so let's look at the left-hand side, 1 minus 2x. So 1 minus 2x. Well, that's 1 minus 2 times 4, since x is 4, which is 1 minus 8, which is negative 7. Okay, left-hand side is negative 7. Okay, now let's look at the right-hand side. Remember, x equals 4. Okay, that means we've got 7 plus x, which is 7 plus 4, which is 11. So negative 7 equals 11. Well, that ain't right. Negative 7 is equal to negative 7. 11 to 11. They aren't equal to each other. Well, what does that tell me? That tells me somewhere along the way I made a mistake. So that's the cool thing. As you can see, if we do the rules, we'll always get this the right answer. And we'll always, when we end up, we're literally just saying like 3 is over 3. And if we want to check, we can just plug it back in. And if they're not the same number, well then we know we messed up somewhere along the way. Okay, so that's what I meant by the fundamental theorem of algebra and algebraic manipulation. Hopefully that helped. Now finally, we're on to inequalities. I'm actually not going to do the rest today. It's getting kind of late. And you'll probably be a bit before I'll touch the lines. I might do it later. Okay, so next, and so it's probably going to be pretty long. Next, we have one variable inequalities. Okay, so let's think of something. Okay, 7 is greater than 2, right? Seven is greater than 2. Okay, well, now let's say that we had some, well, what's 7? 7 is equal to 10 minus 3, right? And 2 is equal to, actually 2 is equal to 6 minus 4, right? Both these things are true. Let's say x was equal to 3. Well, then we're saying that 7 is equal to 10 minus x, and 2 is equal to 6, which is 3 times 2. So, or really I should say 2 times 3, and since x is 3, that's 2x minus 4. And again, you can check 10 minus 3 is 7, and 2 times 3, which is 6 minus 4 is 2. Well, this is the exact same thing as saying that 10 minus x, which is 7, is greater than 2x minus 4. Now, here's the weird thing about inequalities. There's a lot of values in which this is actually going to be true. The cool thing is when you're doing with that exact equality, there's so much you can do. With inequalities, there's still a lot. I mean, you can still use basically the same tools. Any isotonic function, but we don't need to get into that. But there's a lot of values that do that. So, for example, x could be 0, right? 10 minus 0 is greater than 2 times 0 minus 4, because that's saying 10 is greater than negative 4. I mean, yeah. Okay, so we know that. So we know x could be 3, x could be 0. What are all the values of x? That's what we're saying. So we're saying if we're given some inequality like 10 minus x is greater than 2x minus 4, what are all the values of x that satisfies this inequality? Okay, so now I'll tell you some. So there's special rules for inequalities, and if we add a number to both sides, even if it's negative, which in other words, if we add or subtract a number to both sides, it doesn't change it. Okay, and so that's all we're actually going to need to know. And from there, we can actually solve this whole thing. All we're going to be doing is adding. Okay, and then I'll show you another one in which it uses negative numbers. I showed you this before, but hopefully it'll make more sense. But yeah, all you need is addition and technically subtraction, which is just adding in the negative of a number. Okay, so what's first? Okay, we want to isolate the x's. Okay, this x is bigger, right? So we could add x to both sides. And since x is just a number, so remember, like let's take the 7 is greater than 2. So this is gonna be true when x equals 3. Then, and this just means basically then 7 is greater than 2. Okay, so if 7 is greater than 2, and we just add a x over 3 to both sides, that will say 7 plus 3, that's 10 is greater than 2 plus 3 is 5, so 10 is greater than 5. That's still true. So we can add x to both sides, and this will still hold. Okay, so now let's look at the left-hand side. 10 minus x plus x. Well, 10 minus x plus x is just 10. So 10 is greater than 2x minus 4 plus x. Well, that's 3x minus 4. Okay, so I'll actually do this over here too, just so it'll make more sense. So 7 is greater than 2 plus 3 plus 3. 10 is greater than 5. So this is actually what we're doing once we know what x is. Saying 10 is greater than 2, so 10 is greater than 5. Okay, cool. Now, over here, let's see what we want to do. Okay, we want to isolate x. So how do we do that? We want to get rid of this pesky 4 on this right-hand side. So we need to add 4 to both sides. So plus 4 plus 4. Okay, what's 10 plus 4? That's 14. Which is greater than 3x minus 4 plus 4, which is just 3x. So 14 is greater than 3x. Okay, let's look at this side. So all we're saying is writing 4 to both sides. So 10 is greater than 5. Now we can add 4 to both. So 14 is greater than 9. 14 is greater than 9. Cool. Now we're almost there. So we want to find x, so we divide both sides by 3. Because 3x divided by 3 is x. So now we want to look at the left-hand side. So that's 14 divided by 3. Okay? So that's 14 thirds. And 14 thirds is going to be 4.6 repeating. So in other words, it's 4 and 2 thirds. Just depending on how you want to write it. I'll write it as 14 thirds. And then 3, oh, sorry, I just told you that we're just going to do addition and subtraction. So let me keep true to that. Oh, it's so much easier to do multiplication. Okay, let's see. I should have done the other way around. Okay, so let's rewrite this. Okay, yeah. So we use this thing, so it's 14 divided by 3 is 3. So 14 is equal to 14 thirds plus 14 thirds plus 14 thirds. Right? Because 14 plus 14 plus 14, well, that's 14 times 3. And then we're divided by 3, which is just 14. Okay, so 14 thirds plus 14 thirds plus 14 thirds is equal to x plus x plus x. Right? We are just rewriting how we're summing this. Okay? Well, now what can we do? Well, we can see that we've got 3 copies of the same thing on both sides. So that means we can just look at one of these since they're all identical, which is like division by 3. I should do multiplication first. I'll do multiplication after this. Hopefully that makes sense. 14 thirds is equal to x, right? Oh my gosh. I'm sorry. I'm so sorry. 14, this is greater than. So 14 thirds plus 14 thirds plus 14 thirds is greater than x plus x plus x. Okay? So 14 thirds is greater than x. So what that means is this relationship up here holds if x is less than 14 thirds, which means x is going to be like, if you look at the integer, so x could be 4, x could be 3, x could be 2, x could be 1, x could be 11 thirds. And cool thing is when this is now, if we actually plug in 14 thirds, we'll get that these sides are equal. And now 1's not greater than 1. So that's cool. Let me do one more example. Let me just do one more example. So you got negative 3x is greater than 9. Remember, x is an actual number. We just don't know what x is here. Okay, so now you know like the multiply by negative number or divide by negative number, flip the sign. So let's multiply this by negative 1. So now, so we'll times this whole thing. Actually, I'll make my times a dot so it doesn't look like an x. Times negative 1. Okay, so how do we do that? Well, let's think about it. So what does multiply by negative 1 mean? Well, it means I have minus 1 x times of something. So if I, like 3 times 2 is equal to 3 plus 3. So we got 2 copies of 3. And what 3 times negative 1? That's equal to negative 3, right? It's a negative copy of 3. It's negative 1 copies of 3. Okay. Well, how do we do that? So we need a negative copy. Okay. Well, I'll just get a punchline. So negative 3, negative 3x is greater than 9. Okay, so let's add 3x to both sides. And negative 3 times negative 1 is equal to 3. So 3 is negative 1 times negative 3. But let's add 3x to those sides. Okay, negative 3 plus 3x greater than 9 plus 6. Since we're just adding a number, it's fine. We don't need to swap the signs. Okay, so negative 3x plus 3x is just 0. So 0 is greater than 9 plus 3x. Okay. Now, 9 times negative 1 is negative 9. So now let's actually add negative 9 to both sides. So plus negative 9 plus negative 9. Okay. So 0 plus negative 9 is negative 9. So negative 9 is greater than, and 9 plus 3x plus negative 9 is just 3x is greater than 3x. So actually when you multiply by negative 1, it's you're literally that's the same thing as this procedure. These are equivalent. You're literally moving this over here and you're moving this over here. So now we see and we're flipping them. So now we see negative 9 is greater than 3x. Okay, well, that's the same thing as saying 3x is less than 9. So we got negative 3x is greater than 9. Multiply it by negative 1. Negative 3x times negative 1, that's 3x. Okay, 9 plus negative 1 is negative 9. And they tell you to flip the sign, so if it's greater than, it becomes a less than. So greater than equal to becomes a less than equal to. And hopefully you see why now. That might have been somewhat confusing, but hopefully that makes sense. Okay, now I'm gonna do one last example. So here's a railroad application. So let's say that, oh no, let's say that you're for some reason, you're adult now and you don't want to mow your own lawn. It's just too much work. And so you want to pay a lawn mowing company. And now there's two lawn mowing companies. There's company A and there's company B. So we've got, and so what they're gonna do is, and now let's say that you're crazy and you mow them like once a week, and so you want to figure out which company's better. So company A, what it does is you have to pay it $50 a week. $50 a month. So you could now even get your lawn mowed a simple time. There's going to be a $50 flat fee. And based on the estimate of your grass and what you want, they're going to charge you $25, or not $25, $125 each time they come to mow your grass. So let's say example, your grass, it's like the middle of summer, so the grass ain't growing that much. And so you do it, you get your lawn mowed twice by them, because you gotta Augustine. I don't know, this is a complete hypothetical. Okay, so first of all, we got a flat fee of $50. So we've got 50. And then since you got it mowed twice, that's gonna be 2 times 125. Okay, so now let's do the math. So we've got $50 plus 2 times 125 is 250. So, and then $50 plus 250, that's 300. So if you get your lawn mown twice a month, it's going to cost you $300 a month. Now let's look at company B. So this one only has a $20 fee. But now let's say that they charge $135. So this is our, one second. So only $20 a month, but they charge $135 each time you mow your lawn. And again, let's say that this month you only got your lawn mowed twice. So you got your $20 flat fee plus 2 times your service fee because you got their service twice since they mowed your lawn twice. So that's 20 plus 2 times 135. Sorry, part of that 2 got cut off. Okay, so that's 20, and then plus 2 times 135. 135 times 2 is going to be 270. Sorry, plus 270. Okay, and so 20 plus 270 is 290. So in this case, company B wins. But now you want to figure out what company's gonna be better based off how many times I mow my lawn. So X is gonna represent how many times we mow our lawns. So now we've got the question, when is company A better? So let's figure out what the expense for them is. Okay, well, X is gonna be lawn mows per month. Well, a policy of A is going to be going to be 50 plus 125x. So 50 is our flat fee, and then this is our service fee, and this is how many times we have their service, how many times we get our lawn mowed. Okay, now we want to figure out One, company A is better, so it's cheaper, so it's less than company B's prices. Okay, so now company B charges a $20 flat fee and $135 service fee. So it's going to be 135 times X, where X is how many times you get a lawn mown per month. Okay, so now we want to solve the system. Okay, well, this X is greater, so I'm going to move this over here. So we're going to subtract 125X on both sides. Okay, what do we get? On this side, we get 50, which is greater than 20 plus 135X minus 125X. So that's 20 plus 10X. So 50 is less than 20 plus 10X. Okay, now we want to move this over here, so we subtract 20 from both sides. Now 50 minus 20 is 30. 20 plus 10x minus 20 is 10x. So we got 30 is less than 10x. Okay, so divide both sides by 10. Okay, 30 divided by 10 is 3. And 10 divided by 10 is just x. Okay, so we get 3 is less than x, or x is greater than 3. So what does it tell us? That tells us if x is like 4, then company A is cheaper than company B, because even though it has a bigger flat fee, the $10 cheaper per mo actually catches up by that time, such that it's cheaper. Which makes sense, because if you look at the difference between these, that's $30 just more for your flat fee, and this is $10 less. So that means even though this is $30 more for a flat fee, it's $40 less per with all the mo's, so you're going to be $10 cheaper. If x is 3, this actually means they're equal, and if you do the math, it's 425. But now if x is like 2, well, 2 is not greater than 3. That means A is not cheaper. So if you're doing 1 or 2 times, the company B is cheaper. So what does this tell us? This tells us 1 to 2 times the company B wins. 3 times is a tie, it doesn't matter. And 4 times or higher is company A. Now, I personally mow my lawn, or my parents' lawn, once a month, but we don't have like St. Augustine. So I would go with company B. No, I would actually go with company mowing it myself. But okay, so that's a real world example. Hopefully that helped. And yeah. But this kind of thinking, if x equals x and fx equals fx, this is at the heart of algebra, or at least the algebra. Yeah, this is the heart of algebra. You're going to be taught algebraic manipulation. Now, algebra is kind of a misnomer, since now there's a modern field of math that's looking at structures, we call algebraic structures, but that's something completely different. But the algebra that y'all will know and that you're taught, and the algebra that you think of, this is the complete structure. This is the fundamental thing of algebraic manipulation. All algebraic manipulation is really going to follow from if x equals x, then fx equals fx. And we're going to use that kind of same logic for inequalities and stuff. And just remember for inequalities that multiplying by -1 is really like if we subtracted the numbers from both sides and we like swapped them and stuff. So that's what you can do. Instead of like multiplying by -3, you could do it where you subtract both sides and then you multiply by 3. So actually, I'll show you that one last thing. So let's say, I don't know, x is greater than 5. Okay, so now we want to multiply both sides by -3. Okay, so instead of multiplying this by -3, I'll do a dot, else it's going to look really weird. Times -3. What we can do is first flip it. So we'll subtract an x from both sides, and we'll subtract a 5 from both sides. X minus 5, well, x minus x is 0, 0 minus 5 is minus 5. This is minus 5, and this is greater than, well, look, it's 5 minus x minus 5, and 5 minus 5 is 0, and 0 minus x is minus x. Now we're here, let's multiply this by 3, okay? Minus 5 times 3 is 15. So we get -15. It's greater than minus x times 3, which is -3x. And now that means negative 15 is greater than negative 3x, or negative 3x is less than 15. Now let's do this side. So let's just multiply it by negative 3. So x times negative 3, that's negative 3x. 5 times negative 3 is negative 15. And you said that's greater than, well, now we make that less than. So I know I did that before, but hopefully that kind of cements it. So that's all I have to say now. Have a good rest of your day.